Finally, let's talk about this graph, this time involving secant. How should we work out the way that this particular function is going to be graphed? In this case, secant is a graph that's based on what happens to cosine. So we'll work with a similar function, cosine, right here, and use that as our guide. For cosine, if we had y was equal to the negative cosine of x over 2 as our argument, plus 2, what's happening here? Well, our amplitude in this cosine function is equal to 1. There's a reflection with the cosine function, so that's going to change the direction of our curve. However, we know that the period is equal to 2 pi divided by 1/2 in this case, which is to say a period of 4 pi. That's a 1/2 down here, okay? So our period is 4 pi, and of course, key points occur at 1/4 of the period apart, so 1/4 times 4 pi means that our key points occur at pi apart. Now, there's nothing added or subtracted to this increment, so there is no phase shift in this particular case. So that's good for us, no phase shift. There will be a vertical shift. There will be a vertical shift of 2 upward. So we'll use that in a little bit. Shift up by 2. Okay, so how will we use this? Well, in our graph, if we were going with a cosine function, normally we would see the following. For the cosine function, our period, there's no phase shift right here, so for x, we're going to start with 0 this time. Our key points are pi apart, so pi is the first key point there. 2 pi, 3 pi, and of course 4 pi. That's one full period of the function. So what's going to happen here is that when we're graphing this, we want to get the proper y values that go with it. Now, if we're thinking about the secant function, we're going to have vertical asymptotes wherever cosine is 0. So let's go through our normal cosine period. Normally with cosine, we start with 1, 0, -1, 0, and 1. What's going to happen here is that wherever the cosine function was equal to 0, our function would have a vertical asymptote, and that's at pi and 3 pi. So we've got 2 asymptotes here within one cycle at pi and 3 pi. So pi, 2 pi, 3 pi. Here's 4 pi right here. Let me mark off the increments here along my x-axis. Here's 2 pi. Here's 0. Here's -2 pi, and so on. Okay, so vertical asymptotes are definitely going to occur at pi and at 3 pi within this one cycle. So now we'll want to look at how our cosine function works. In this case, cosine would be, we're going to multiply by a equals -1, so we'd be multiplying by -1 and then adding 2. So that means that we're going to be at +1 here at this case. 1 times -1 is -1 plus 2, that's 1. We're going to multiply -1 times -1 and then add 2 to this value, so we're going to get +3 in this case. Our y value of 1 normally for cosine would be 1 times -1 added to 2, right? That's our vertical shift, so we're going to be back to +1 this time. And it would look like our cosine function, if we were graphing that, would be passing through the point with a center axis at 1. The cosine function might look like this. It would start at 0. It would go up to it would go down, pardon me, to positive 1. Oh, here's 2. Let me adjust this 1 second. All right. Our center axis is up 2, pardon me, so we're going to have a center axis here at 2. And normally, if this were a cosine function, we would go down to negative 1. Or we'd start. Good Lord, I can't even get that right? Let's try that again. We'd start at negative 1 here for cosine. It would come up, our cosine graph, and look like this. So I'm dashing in the graph of y equals cosine, negative cosine of x over 2 plus 2, but our y values this time for the secant function are going to be 1 at 0, and it will go down towards the vertical asymptote since we're reflecting from the normal shape. We'd come down along our vertical asymptote, go down as low as 3, and then go back up towards positive infinity. And then we would graph from 3 pi off to 4 pi by this vertical asymptote going up to as high as positive 1 again. And this is what our function would look like. Now, there's a couple of reasons that we wanted to make sure that we did all of this. One was that we would be able to get the nice shape. We could show this over as many intervals as we wanted to. But the other thing is to find our domain and range. Okay, so what do we do right here? Normally, the domain of a secant function was going to be the set of all x values such that x was not equal to odd multiples, which we wrote as 2n plus 1, odd multiples of pi over 2. But what we do to adjust for our new domain is that we set our argument x over 2 not equal to that. Well, if we multiply both sides of this inequality by 2, we get x is not equal to 2n plus 1 times pi over 2 times pi. Well, that's times pi. So our domain is the set of all x values such that x is not equal to odd multiples of pi. And that seems to fit with what we're saying right here. 1 pi was our vertical asymptote here. 3 pi was our next vertical asymptote. One suspects that our next vertical asymptote would be at 5 pi, and it would. If we were to graph this out another cycle, we could certainly do that. All right. How about our range? Well, the other thing that changes here is that on the basis of that vertical shift, right, if we were drawing a cosine function, cosine would be between 1 and 3. Right? For cosine, that would be its range. But since we're dealing with secant, the range then will be limited by the 1 and the 3 as well, but it'll go negative infinity to 1. It will include 1. Union with the set from 3 to infinity this time. Right? So a vertical shift helps change that range value that we're looking for. All right, guys, good luck on your homework. See you in class.